So let's talk about how we are going to perform these hypothesis tests. So first, you have to remember to check the 3 requirements that were discussed in the last video. Then you determine the null and alternative hypotheses. And these can be structured in one of 3 ways. If H0 is P equal P0, which it's always going to be, and H1 is P not equal to P0, that's a two-tailed test. And so what that looks like is if we have our normal curve, we're looking at the 2 tails and the probability in those 2 tails. If we have our null hypothesis is P equals P0 and H1 is P is less than P0, then we have a left-tailed test. And so what that looks like is if we have our normal curve, we're looking at the area to the left to get our probability. And the third option is if we have P equals P0 and H1 is P is greater than P0, then we have a right-tailed test, which means we have a value and we just go to the left of, to the right of it, sorry. Remember, P0 is the hypothesized proportion. Okay, after we make our hypotheses, then we want to select an alpha. That's our significance level, remember. And it's usually given to us in the problems. Now, in the real world, you have to decide what your own alpha is, but we don't usually have to. And I don't know why I wrote significance level up there since it goes right here anyway. So select alpha, our level of significance, depending on the seriousness of making a type 1 error. And remember, a type 1 error is when we reject the null hypothesis, but the null hypothesis is really true. Then, using technology, we want to compute the test statistic which we call Z0 sub 0, so like Z null, when we do it, but the calculator gives it to us as Z. And we also need the p-value. So on the calculator, you're going to press stat and then use the right arrow key to go to the test menu. And for proportion, you want 1 prop z test. Now, you can help remember this by prop stands for proportion, and we're testing a proportion. And the test is short for hypothesis test. You identify the population proportion, P0. Then you put in the values for X and N. Remember, X is the number of people with the characteristic we're measuring. And N is our sample size. Then we identify the type of test. So if it's two-tailed, we want to pick the not equal P0. If it's left-tailed, we want to pick the less than P0. And if it's right-tailed, pick the greater than P0. Then highlight, calculate, and press enter. So for the test statistic here, the calculator says Z, and we write Z sub 0. The p-value, the calculator says P, and we write p-value. The other way we can do this is in StatCrunch, and this will help with your homework. So if you're in StatCrunch, you click Stat, and then go to Proportion Stats, and then one sample, and then with summary. You identify the number of successes. Remember, that's the same thing as X in the calculator. The number of observations, N, which is our sample size. And then select Perform Hypothesis Test for P. H0 equals, and you put the proper number in for P0. Then HA, you pick the correct symbol. So remember, that's either going to be not equal, less than, or greater than, depending upon the kind of test you have. And remember, HA is just another name for H1, A for alternative hypothesis. Then you can select compute, and StatCrunch says Z stat, but we write Z sub 0. And StatCrunch calls the p-value the p-value, and we write p-value. So what we write doesn't change, it's just what they label it changes. Then we compare p-value to alpha and make a decision. If the p-value is smaller than alpha, we reject the null hypothesis. And remember, that's if the p is low, the null must go. If the p-value is greater than or equal to alpha, we do not reject the null. And it has its own little saying, which I don't like, but I'll give it to you anyway. If the p is high, the null will fly. And that means it's okay, so we do not reject it. I recommend you just remember the one for low, and if it's the opposite, then you know that you have to keep it. And the last thing we do is state the conclusion. So we state our decision regarding the alternative hypothesis. And we have to be sure to turn the parameter back into the context of the problem to state our, our level of significance. And we'll pick up with the examples in the next video.